projects. In this video, we are going to explain about a project titled A Novel POI Recommendation Method Based on Trust Relationship and Spatial Temporal Factors. Now coming to the introduction part. The introduction of this novel POI recommendation method represents a significant advancement in the field of location-based services. By considering trust relationships and spatial temporal factors, the method enhances the precision and relevance of POI recommendations, ultimately leading to increased user satisfaction and engagement. As the digital landscape continues to evolve, this innovative approach is poised to shape the future of personalized POI recommendations and contribute to the seamless integration of technology into users' everyday lives. The proposed method incorporates trust relationships as a fundamental aspect of the recommendation process. In today's digitally connected world, users often rely on recommendations from friends, family, or other trusted sources when making decisions about places to visit. By integrating trust relationships into the recommendation model, the system can factor in the preferences and feedback of trusted individuals, elevating the credibility and reliability of the suggested POIs. So our main objective for this project is the novel POI recommendation method based on trust relationships and spatial temporal factors aims to revolutionize the way POIs are recommended to users in location-based services. By incorporating trust relationships, considering spatial and temporal context, and personalizing recommendations, the method tries to offer more accurate and contextually relevant suggestions. With its focus on user satisfaction, engagement, and continuous improvement through user feedback, this innovative approach has the potential to transform the landscape of location-based recommendation systems. Enhance recommendation accuracy. The aim of the method is to enhance the precision of POI recommendations. Through the utilization of trust relationships, the system can consider the preferences and input from individuals held in high regard, resulting in recommendations that are both dependable and fitting. Personalizing recommendations. The innovative approach strives to offer customized suggestions that cater to the unique preferences and requirements of each individual user. Contextual relevance. The integration of spatial and temporal factors enables the recommendation system to provide more contextually relevant POI suggestions. Handling user feedback. The method's algorithm takes into account user feedback on recommended POIs. As users interact with the system and provide feedback, the algorithm refines its understanding of their preferences and adapts the recommendations accordingly. Now coming to the requirements part, we have two types of requirements, that are hardware requirements and software requirements. So in hardware requirements, first we require operating system, that is Windows, processor i5 and above, minimum 4 GB of RAM is required, hard disk 20 GB and above. Coming to the software requirement part, Python IDEL, that is 3.7 version. Now coming to the methodology part, first we have upload Govala dataset. The first step in this process is to upload the Govala dataset, which contains information about user check-ins at various places. Govala is a location-based social networking service where users can check in to different locations and share their experiences. This dataset serves as the foundation for the personalized recommendation system. Second, extract users and places preferences data layer. After uploading the dataset, the next phase involves extracting users and places preferences from the data. This data extraction process involves analyzing the check-ins made by users to understand their interests and preferences in terms of places they visit. Third, run matrix factorization method layer. It is a widely used technique in recommendation systems to uncover latent factors that influence user preferences and item characteristics. In this method layer, the system applies matrix factorization to decompose the user place interaction matrix into lower dimensional latent factors. It helps in discovering underlying patterns and relationships between users and places, making the recommendation process more efficient and accurate. Fourth, run func-spd algorithms application layer. Func-spd is a singular value decomposition, which is a specific type of matrix factorization algorithm often used for recommendation tasks. In the application layer, the system applies func-spd algorithms to further refine the latent factor representation obtained in the previous step. By iteratively optimizing the factorization process, the system fine-tunes the model to better capture user places, preferences, and generate more precise recommendations. Fifth, matrix graph. To evaluate the performance of the personalized recommendation system, various metrics are computed to measure its effectiveness. The system generates a matrix graph that displays the performance of the recommendation model over time or iterates. 6. Exit. Once the personalized recommendation system has been developed and evaluated, the exit phase signifies the completion of the process. The system is now ready to provide personalized POI recommendations to users based on their preferences and historical check-in data from the Gowala dataset. Now coming to the execution part. To execute the project, first we need to open the code folder. Here you can see we have two folders. This folder name is the dataset, which are containing the datasets in its .csv file. This folder named as model containing the txt file. Here, this is the Python file which contains the Python script in it. And this is the run.bat file. Instead of executing the program in command line interface, we created Windows bat file to execute the project. Now to run the project, double click on bat file to execute the project. This is the graphical user interface. With this we are interacting with the program. Now click on upload Gowala dataset button to upload dataset and get the output. Click on open. Here we can see selecting and uploading over here the dataset. Now this dataset loaded over here. Now click on extract users and places preferences data layer to extract users places preferences from dataset and build a dataset layer. And over here we get the output. So here we can see this is screen. It displaying extracted some users and preferences details. Now click on run matrix factorization method layer button to build matrix by using user details, place and preferences for getting the output. Here on this screen, matrix factorization generated from users, places, trust and preferences. Now click on run func-spd algorithm application layer button to take any user as input and then calculate POI and recommend to user by using func-spd and similarity algorithm. Now in this screen dialog box, enter any name from dataset for POI recommendation. Here I am entering Here I have entered this name from the dataset. Now click on OK. Here, by pressing the OK button, we can see on this screen for selected user we got 10 top POI recommendation over here, and then displaying accuracy, precision and other matrix values. And similarly, you can enter any user name and then get POI recommendation. Here on this screen, in first line, we are displaying username and then displaying recommendation places. Now click on matrix graph button to get the graph. Here we can see that we are plotting graph with matrix obtained from Funk SPD prediction for POI recommendation. Now, closing this project, by clicking on exit, we can end up with the project. Now, coming to the conclusion part, the primary objectives of the method including enhancing recommendation accuracy, providing personalized and contextually relevant suggestions, improving user engagement, and handling user feedback have been successfully achieved. As a result, the novel POI recommendation method has the potential to significantly enhance user satisfaction and user retention in location-based services. As the digital landscape continues to evolve, this innovative approach is poised to shape the future of POI recommendations and contribute to the advancement of location-based service platforms. By bridging the gap between user preferences, trust relationships, and spatial temporal factors, the novel method represents a crucial step towards creating a seamless and satisfying user experience in the world of location-based recommendations. Recognizing that users' preferences for POIs can vary based on their current location and the time of day or week, the method adapts its suggestions to suit each user's unique situational context. This personalized approach ensures that users receive relevant recommendations tailored to their immediate needs, enhancing the overall user experience.
For updates on latest project videos, please visit True Project's YouTube channel and subscribe.